Hello children, welcome to Samveda e-learning classes for 6th standard mathematics. Children, this is first session of the lesson basic geometrical ideas. Children, there are three branches in mathematics. They are arithmetic, algebra, geometry. Arithmetic consists of counting, study of number, basic operations, addition, subtraction, multiplication, division and so on. In algebra, we learn about variables, constants, expressions, equations, polynomials and so on. Geometry is a branch of mathematics that deals with sizes, shapes, positions and angles, dimensions of things. Geometry has a long and rich history. The term geometry is the English equivalent of Greek word geometron. In geometron, geo means earth and metron means measurement. Children, look at this picture, that is Euclid. Euclid was a Greek mathematician often called as the father of geometry. So, these are the books. Element is written by Euclid. It was the first mathematics textbook. According to historians, the geometrical ideas shaped up in ancient times, probably due to the need in architecture and measurement. Construction of palaces, temples, lakes, dams and cities, art and architecture propped up these ideas. Even today, geometrical ideas are reflected in all forms of art, measurements, architecture, engineering, cloth designing and so on. You observe and use different objects like boxes, tables, books, the ball with you play and so on. All such objects have different shapes. Look at this figure, pyramids. Pyramids which still occupy a place among 7 wonders of world and whose construction is certainly one of the greatest human achievements. Children, in this session, we learn about basic geometrical ideas. Look at this figure, it is a compass. We can make dot by the tip of the compass, Pencil. By the sharp tip of the pencil, we will mark a dot on the paper. The sharpener the tip, thinner will be the dot. It is a needle. We can make a dot with the help of the pointed end of the needle. This almost invisibly tiny dot will give us an idea of a point. A point determines location. Let us mark 3 points on the paper. You would be required to distinguish the points. How do we notice the points here? By giving the names P, Q, R. By giving the names like P, Q, R. By this, the points are denoted by a single capital letters like P, Q, R, S, A, B, C, D and so on. Look at these points. How do we read it? We read it as point P, point Q, point R. Of course, the points have to be invisibly very thin. Point indicates a position in space. Point has no length, no breadth and no thickness. Children, can you list out some situation which gives the ideas of a point? Okay, let us see some situations. A star in the night sky gives us an idea of a point. Stars are very far away from us, that is why it looks like a point or small dot. Here, location of capital cities of the states in Indian map. The capital cities is represented by the points. For example, the capital of Karnataka is Bangalore. This point shows Lucknow, the capital of Uttar Pradesh. Here this point shows Jaipur, the capital of Rajasthan. Let us see one more situation. Children, you are very fond of the art, that is Rangoli art. Dots are used to draw Rangoli in front of houses. So many dots are here. The Rangoli formed by dots. Look here. Children, look at these two pictures. Pointillism is technique of painting in which small distinct dots of color are applied in patterns to form an image. Here we can see the parrot made by dots. In second figure, we see the Albert Einstein picture made by pointillism technique. Children, now we understood some situations where we will get ideas of points. Children, we will take a piece of paper, fold a piece of paper and unfold it. We will see one mark. It has two endpoints. We will name them as A and B, and look at that mark. This mark gives us idea of a line segment. Let us take a thin thread, hold its two ends and stretch it without a slack. It represents a line segment. The ends holding by hands are the end points of the line segment. Let us consider a situation. An ant can travel in different possible ways to get a sweet. Ant is at the point A, the sweet is at the point B. Ant can travel in different possible ways to get a sweet. First way, look at that second way, it can travel with third way and fourth way. Here ant will get 4 ways, 1, 2, 3 or 4. Which is the shortest way from ant to sweet or from A to B? The way fourth or fourth path is the shortest way. It can get the sweet. This shortest joint of the points A and B shown here is a line segment. It is denoted by line segment AB or BA. It is denoted by the symbol line AB or line BA. Children, let us look at some models for a line segment. Look at this table. Edges of the table are the line segments, and edges of the postcards and edges of the notebook. They are the example for the line segments. Line segment has length but no breadth. Line segment has measurement. Children, now we will find the length of the line segment. The length of a line segment can be measured because it has definite length and it has 2 end points, the line segment measured by a ruler. Let us consider a line segment AB. Place a ruler along given line segment such that A is placed at 0 mark. Read the mark on the ruler against point B. There are 5 small divisions, 1, 2, 3, 4, 5. 5 small divisions after the 4-inch mark. So, the length of the line segment is 4.5 inches. Children, I have taken the unit inches to measure the line segment. Usually, we will take the centimeters to measure line segment. Consider one example. Name the line segments in the given figure. How many line segments are here? There are 2 line segments. First one is line segment AB. Second one is line segment AC. Children, imagine that line segment AB from A to B is extended beyond A in one direction and beyond B in other direction without any end. Can we draw a complete picture of a line? No, it is not possible because the line has no ends. Line contains an infinite number of points. The arrows at the end, the line through 2 points A and B is written as the line AB. It extends indefinitely in both the directions, so it contains a countless number of points. Look at this figure, points A and B marked on the line. Look at both the ends are shown by arrows. The line does not have definite length. In this figure, a line PQ is written as line PQ. Sometimes lines are denoted by the letters like L, M and so on. Children, look at this model. The light rays emerging from a point. This is a torch, ray of light from a torch. Sun rays from the sun, beam of light from a lighthouse. Here light comes from the torch, from sun, from lighthouse in the form of rays. Children, we know what is ray. But what is ray, children? A ray is a portion of a line. It starts at one point and goes endlessly in one direction. Here the ray AP starts at one point and goes endlessly in one direction. 2 points are shown on the ray. They are A and P. A is the starting point and P a point on the path of the way. The endless is shown with an arrow. It is denoted by the symbol, the ray AP. Let us take one example. Name the rays given in this picture. How many rays are here? 2 rays. The ray TA and the ray TB. Here the ray TN and the ray TB are same. Here 2 lines L1 and L2 pass through a point P. We say that L1 and L2 intersect at point P. So, P is a point of intersection. If 2 lines have one common point, they are called intersecting lines. Common point is called as point of intersection. Here P is a point of intersection. Let us see some models of a pair of intersecting lines. Look at this, the letter X. It has 2 axes intersecting at a point. Crossing roads. The roads are intersect at a point. The edges of the notebook. 2 adjacent edges intersect at a point. Dear children, using this figure, shall we naming the geometrical concepts? Line segment, line containing point E. E is on the line AE and also E is on the line FE. Therefore, the lines containing point E are AE and EF. AE is also considered as the line AB, the line AD, the line BE also. Here we took the line as AE. Therefore, line containing point E are the line AE and line EF. Line passing through A. Here a point A, BE is passing through A. Therefore, B is passing through a point A. Line on which O lies. The point O lies on this line, that is CO. Point O lies on CO or OC. Here, two pairs are lines intersecting. OC and AE intersect OC at B. EF intersect AE at E. Children, draw a rough figure and label suitably in each of the following cases. Children, try to draw in your notebook. Point P lies on line segment AB. Let us take one line segment. End points are A and B. Mark a point P on AB. Now, we get the figure. Point P lies on the line segment AB. The line XY and the line PQ intersect at M. Let us draw the line XY and also the line PQ. These two lines are intersecting at a point M. Are you writing, children? Good. Next one. The lines OP and OQ meet at O. Let us draw the point O, the line OP, another line passing through O, that is OQ. Therefore, these two lines meet at O. Consider the following figure of line MN. Say whether following statements are true or false in context of the given figure. First statement, Q, M, O, N, P are points on the line MN. Is it correct? Q, M, O, N, P are the points on the line MN. Therefore, this statement is true. Take second one. M, O, N are points on a line segment MN. Consider the line segment MN. M, O, N are the points on the line segment MN. Therefore, this statement is true. Next one. M and N are the end points of line segment MN. M and N are the end points of the line segment MN. So, this statement is true. Let us take one more statement. O and N are end points of line segment OP. Look at this line segment OP. Here, O and P are the end points of the line segment OP. Therefore, but not O and N. Therefore, the given statement is false. Next one. M is one of the end point of the line segment QO. QO is a line segment, but M is not the end point of line segment OQ. So, this statement is false. Let us take the ray OP, but M is in different direction of OP, but it is not a point on the ray OP. Therefore, this statement is false. Next one. Ray OP is different from ray QP. Ray OP is different from ray QP. Yes. So, the ray OP has the initial point O, the ray QP has the initial point Q. Therefore, the OP is different from ray QP. So, this statement is true. Let us take one more statement. The ray OP is same as the ray OM. Look at here, the ray OP is not same as the ray OM because they are in different directions. Therefore, this statement is false. Children, to confirm these geometrical concepts by doing an activity. Children, let's do an activity. I am taking the models of lines. These models are made by broomsticks. They have arrows on both the ends. Arrow shows endless. Children, consider these sticks as lines. Let's take two sticks. Two lines are intersecting each other at any point. First line, second line. These lines are called intersecting lines. This point is called point of intersection. Now we will keep two lines which are parallel to each other. The distance between two lines is 7.5 centimeter. These two lines shows parallel lines. They are in equidistance at any corresponding points. Let's consider a point. I am taking a model of a point, but we know point is invisible dot. Children, how many lines passes through this point? Let's see. Here I am taking one line and keeping the line on a point. First line passes through this point. Second line keeping on the same point. Third line. Fourth line is passing through the same point. Fifth line. Like this way, so many lines are passing through this point. Now we understood that infinite lines can pass through a point. Children, here these lines are called intersecting lines. Already we knew two or more lines intersecting at a point, that lines are also called as concurrent lines. That point of intersection is also known as point of concurrence. I am taking models of 2 points, 1 and 2 points, 2, 1 and 2 points. We can see that now we can see that only one line passes through 2 points. The rest are intersect at only one single point. So, we will get to the conclusion that only one line passes through 2 distinct points. Children, let us discuss. Can 2 lines intersect in more than one point? No, it's not possible. 2 lines intersect at one point only. Can more than 2 lines intersect in one point? Yes, more than 2 lines intersect in one point. Look at this figure. The lines L1, L2, L3, L4. They intersect at one point. The lines L1, L2, L3, L4 are also called as concurrent lines. If two or more lines intersect at any point, then they are said to be concurrent lines. Let us discuss about parallel lines. Look at this table. It has flat top named as A, B, C, D. We can see some points and line segments. The line segments AB and BC intersect at B. The line segments AD and CD intersect at the point D. Do the lines AD and AB intersect? AD and AB, yes, they intersect at A. Do the lines AD and BD intersect? No. The line segments AD and BC do not meet or do not intersect at any point. Opposite lines like these which do not meet are said to be parallel and are called parallel lines. Two or more lines are called parallel lines if they do not meet each other at any point. Look at this example. Here the line AB is parallel to line CD and also the line L is parallel to line M. It remains same. Here the distance between these two lines is 4 centimeter. Parallel lines are denoted by the symbol parallel to. Here two lines AB and CD are parallel and represented as AB parallel to CD, otherwise the line L is parallel to the line M. Let us identify parallel lines in the figures. Look at this ruler or a scale. In this ruler, the two edges are parallel. It is window. The crossbars of the given window are parallel. Railway lines are always parallel. Children, you are very curious for this time, that is task time. Which of the following has definite measurement? Point, ray, line, line segment. Which is the correct answer? Yes, line segment has a definite length, definite measurement. Second one, in this figure DF represents. Options are ray, line, line segment, point. Here it has one end point and one side the arrow mark. Therefore, DF is a ray. How many lines can pass through a point? Options: only one line, only two lines, 0, infinite. Children, already we knew the answer, infinite. Infinite, the number of lines can pass through a point. Children, it is time to note down the questions. Write down in your notebook. First question, using the given figure, name the following: 5 points, 5 line segments, 4 rays. Name any 2 pairs of parallel lines and name any 2 points of intersection. What we have discussed in today's session? Point, a line segment, a line, intersecting lines, parallel lines. Children, it is the end of the session. Children, stay safe, stay home, keep learning. When you go outside, don't forget wear a mask. This is Shashikala SC, working as TGT, Government Model Primary School, Konanakunte, Bengaluru South 3. Thank you.